Hello viewer, good day to you. So, are you someone who's looking for ways to secure certain important files or folders on your machine? If so, then this video is for you. In this video, I'll be talking about basic file encryption methods and the softwares which can help you to do that for free. And finally, I'll show you the software which I have built myself and I'll tell you why I have made it and also demonstrate to you in detail how to use it. Now, if you're not already familiar with what encryption is, here is a brief rundown. Encryption is just a way to convert some input data, in our case some important files, into some kind of output format or a file which is filled with garbage data that makes the data totally unreadable and unusable. Now the opposite of encryption is decryption, meaning you are turning those unreadable and unusable files to readable and usable ones. So with that out of the way, let's go with the next question. What are some methods to encrypt your files? So, when we're talking about the methods to encrypt our files, we had to choose a a thing called as an encryption algorithm. An encryption algorithm is also termed as a cipher algorithm, uh, and all the cipher algorithms uses some form of a cipher key. The key helps to encrypt and decrypt your files or data, but these algorithms are broadly categorized into two ciphers. So one of them is symmetric cipher and the other one is asymmetric cipher. The asymmetric cipher is also called as a public-private key algorithms. But the symmetric ciphers are those where you encrypt and decrypt the data using a single key. So that's what asymmetric cipher is. We are encrypting and decrypting using the same key. But in the asymmetric ciphers, we have a public key and a private key. So we have to maintain two different keys to do the operations. The public key is the one which you use to encrypt the data, and the private key is the one which you use to decrypt the data. So some of the popular symmetric ciphers are AES. It's also called AES is a standard, and the algorithm behind it is Rindal. And then we have Blowfish and Twofish. And some of the famous asymmetric ciphers are RSA, Diffie-Hellman, and elliptic curve. Now, it is obvious to us that we need to investigate symmetric ciphers in particular and not the asymmetric ones, because in the latter, um, we need to maintain two different keys all the time, and also such ciphers take longer time to encrypt and decrypt the data because your key sizes are way too big. And that's in the case of asymmetric ciphers. But in the symmetric ciphers, the keys are not that big. You can either have a 128-bit key, a 192-bit, and a 256-bit. Those are the three prominent variants of the key sizes. And the most famous symmetric cipher is AES. So in this video, we'll be using those softwares which has AES under the hood. So the AES algorithm, AES encryption and decryption differs based on the key sizes which are employed. We have AES 128, AES 192, and AES 256. So the general understanding is that the larger the key size, the difficult it is to crack AES encrypted files. Nevertheless, AES 128 is more than enough for almost all the scenarios, and going beyond that is not is just considered as an overkill. Alongside choosing a key size, with AES, you need to choose a mode, and AES has uh, three modes which are quite popular. A mode is considered to be the core algorithm of your AES, and there are several modes for you to choose from, but it depends upon your requirement. For file encryption softwares, we always use block cipher modes, and not stream cipher modes. And the three most popular block cipher modes are, I'll just type it down here. So the three most block ciphers are famously used block ciphers are ECB and CBC and GCM. So each of these cipher modes have their own core logic, uh, separate core logic, and there's a variation between these three. Uh, of these three, the GCM is known to be the best, and it solves some major issues which the other two modes has. So there are some issues with these two modes, but the GCM one is solves those issues, and it is considered to be the highest secure one. Now, what are some popular AES using softwares, and are there any free ones available? So first, let's take a look at the paid ones in 2024. So we have VeraCrypt, we have AXCrypt, Folder Lock, Node Locker, BitLocker by Microsoft, meaning you had to buy Windows in order to use this. And then there's Microsoft OneDrive. Yeah, so these are the paid versions, and then this VeraCrypt, there's also a free version with that, which is more than enough for regular most of the use cases of any regular user. Not only that, but also VeraCrypt is open source software, so you can look at its source code and see whether the software is doing anything shady. Um, but the main question of today's video is, do we need to pay for file encryption in 2024? The answer is yes. If you want some long-term support for with new features and bug fixes, and also the answer is no. If you know your way around with computers, where you can choose open source free software to do the same, and I'll be helping you with that uh, in today's video. So the popular free and open source softwares which I have known by far, which I have known and I have personally used are Lux, and then Descriptor for full disk encryption, and 7-zip for folder encryption. You could also use tools like GPG and OpenSSL, which are part of the GN GNU tool library. So this comes as a lib this these two let me just list them down: GPG and OpenSSL. This comes with GNU tool utility, which will be part of most of the Linux distributions out there. And I have this in my machine, but trying to use these two tools, it's a bit difficult, and they get quite complicated even for veterans. And when you use these tools, GPG and OpenSSL, you have to write some kind of shell script as a wrapper around them so that you can encrypt multiple files. But any shell script or like bash is only limited to single thread, meaning you cannot operate it on multiple threads utilizing your CPU cores. Now here's the thing: if you're looking for if you're looking to use these free software solutions, you must also understand that some of these are easy to use, some of them are not. Some have GUI and some needs to be operated in command line on Windows or Linux terminal and on Linux machines. Nevertheless, I was not fully satisfied with these paid and free software solutions because I do not wish to do full disk encryption on my hard drives or thumb drives. And every time I want to use them, I do not want to decrypt the whole thing. Uh, that's uh, that's too much for me to ask, too much for me to do, and so I do not want to use these tools. And I have reasons to not use 7-zip as well, because when I use 7-zip, it's going to archive my files as a zip file, which will later become harder for me to extract uh, and separate those specific files which I want to have a quick look at. And finally, the one of the major reason I do not wish to go with paid software is trust issues. So what is the solution here? Um, it's very simple. Write my own thing, write my own file encryption software from scratch, and that's the reason why I have built my own file encryption tool. So for the rest of the video, I'll be taking, I'll walk through a demonstration how to use the software, and if you like it, you can uh, you can let me know in the comments. Right, let's just move on. So there is this. I have uploaded this project source code onto GitHub, so you can find the source code for the project at github.com/omkarium/roofanddeck. So that's the name of the project, Roof and Deck. Roof and Deck stands for Rust File Encryptor and Decryptor. So the reason I call this is because this software is built on using the Rust programming language. It's a command line tool. It's not like a GUI where you have buttons to click. It's just simple and lightweight to use, and it uses AES-256 bit key. And the default mode for this tool is GCM. There is another mode, ECB, which is also optional to use. So this tool is made with a specific use case in mind, and I'll talk you through that. But in order to understand what that use case is, it's better to straightforward go into the demonstration. Um, so let's do that. In order to install Roofing Deck, there are three major ways to do it. Two out of the three ways is to do it via Cargo. So Cargo is a package manager for Rust, similar to how NPM is for JavaScript related projects. And so if you have Cargo installed on your machine, then you can just run this command cargo install roofing deck. So that's going to install the program, compile the project from the source, and then it's going to install it in your machine, right? Um, so that's one way to do it. But for that to work, you need to have Cargo installed on your machine. So if you don't have Cargo already installed, you can just go to doc.trustlang.org and just install Cargo using by copying this curl command. Once you run it, your Rust will be installed, and you will have Cargo installed on your machine, right? So let me open the terminal. I'll just show you which version of Cargo I have. I have Cargo 1.7.75. Now, the second approach, it also has to do with Cargo. So the first way, as I've told you before, in order to install Roof and Deck directly onto your machine, you have to do Cargo install Roof and Deck, and that's going to do that. And when you do this, it's going to actually download the source from a repository called as crates.io. So this is the file Rust repository where the actual source code is. Um, if you have Cargo installed, then you just run it, and then it's going to pull the source code from this crates.io, install it on your machine, and then you're good to go. So that's the first version, and then the second way to do this is just copy, download the source code from GitHub. So you can just copy this link, clone it, and then you can compile it using cargo build. So there is this command called as cargo build, and that's going to compile your source code, uh, and you can run this project. So why don't we try that out, right? So yeah, let's do that. I'll just copy this link and I'll just clone it here. All right, I'll say git clone. So I have cloned it. I'll change my directory to roofing deck, and then these are the files. Um, It's not much. I mean, if you check, it's just like 72 kilobytes. Uh, and then I'll just run cargo build. That's going to build the project from the source. Um, so basically, that's going to compile the project from the source code, and then it's going to generate a binary file, a binary executable, which you'll be able to execute in order to run a roof index. Okay, so this is going to take a bit of time. Mm. While this is installing, let's talk about the easiest way to do this. So I have already compiled the binaries for you and I have uploaded them under the release. If you're a Linux user, you can just download this binary file. So the latest version is 0.6.0 for Linux x86 architecture. So you can just download this roof index file and then run it. For Windows users, you can. I do not have the latest version yet compiled, so you have to just go with 0.4.0 by the time of this video recording. So you can just download this roofindex.exe and it's going to and directly run it from your command line. All right, next, yeah, so we have the project compiled. You can see these are the list of libraries which I have used to create this project. Um, if you're someone who understands Rust program, then I can let me know in the comments so that I'll describe what each of this library is actually doing. Um, Now, if you just for an end user purpose, if you just want to run this project, all you need to do is cargo run, and then that has run the project. As you can see, I have ran the project, but it's giving me a usage. I need to give some command line arguments so that it just works in the right way. To see the full description, like if you want to see the help section, you can just say cargo run hyphen 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 help, and this is going to provide you with a help view. Mm, and assuming that you have installed it directly from the releases and or even cargo install roof index, not from GitHub, then you can just try to run the command like this. So I can just run roof index hyphen hyphen help. So roof index is already installed on my machine, and if I run roof index hyphen hyphen help, it's going to provide me a description, provide you a description of the project, the usage, the arguments, and then the list of options. I'll go through each of what these options are and how to use it. So imagine you have uh, a folder like this. So this folder has shell scripts, some text files, and some other folders. So there's a folder 1 and folder 2. The folder 2 has another folder. So this is some Rust code and some CSS files and some keys, some GIF files, and there's a image. And folder 1, I have a JSON, a zip, a PDF, a text file, and there is a video. And on the root we have two shell scripts. All right. So I just want to encrypt this whole thing, which is residing in this folder, encrypt this, uh, and output into a separate folder called as decrypt this. All right. So to do that, all I need to do is I'll just type roof index, and the first argument which you need to provide is the source directory. So, so this is encrypt this folder. That's our source folder, so source directory. So I'll just type roof and deck, encrypt this, or even I can provide a dot here, encrypt this, and then I'll just try to output into a directory called as output. All right, so that's my source, and that's my target, source and target, and the operation which I want to perform. So I can give a short form and a full form. So this is the full form, hyphen hyphen operation, and then I can just say encrypt. Or if I wish to go with the short form, I can just say hyphen O, and I'll say encrypt. So that's going to encrypt the files in this folder, and it's going to put the encrypted files in the output directory. So whatever files which are there in this encrypt this folder, the source directory, those will be encrypted and will be placed into the target directory output. All right. Better to change this name of the output directory as something like decrypt this, because later I'll show how to decrypt it. So it will be useful to name it as like name it as decrypt this folder, and you can pass the number of threads which you want to run this on. So by default, it's going to use 8 threads on your machine. So if you have 4 cores on your 4-core CPU, 4 times 2, it's going to use all the 8 threads. And so my machine has 4 cores, 4 CPU cores, and so I can just provide hyphen T and 8. If you want to, if you are someone who has a machine with a high number of cores, you can just go with that many, 12, 16, 32, and that's if you choose that, it's going to speed the pace of encryption. If you don't provide this parameter, it's going to take the default value. So I will not provide it for now. And there's another option called as hyphen M. M describes the mode, so you can choose either ECB mode or GCM mode. All right, but again, if you do not specify this, it's going to choose the default GCM. So there are two possible values, and it's going to choose the GCM version, GCM mode for encryption. Um, and finally, so there's a lot going on here, right? We need to provide another thing. So there is another option called as hyphen I. So hyphen I stands for the total number of iterations you want to have with your password-based key derivation function. So what this means is, imagine you're trying to encrypt your files with a certain password. Since it's a password, it can be weak. You can choose a very weak password like ABC123 or 12345. But what happens is that's a very insecure way to encrypt your files. So there is a password-based key derivation function which I have used, which will take your password, even if it is weak. Based on the number of iterations you choose, it's going to create a random key, a very random key, but every time you pass this, you give the same password, it's going to generate the same key, which will be used for your encryption and decryption, right? So by default, the total iterations is 6,000, and if I want to go with a higher number, I can choose that. So the higher the number you choose, the more complicated your key is going to be, and it's going to take a longer time for the key generation. So I'll just go with the default one, which is 60,000. And so that's all it is. That's all there is. And then there's this two main things. One is the password file, and then a hyphen D parameter. So what does this do? Or what does hyphen P do? So hyphen P, if you have a password file with you, like I'll just show what is a password file. So so this is a password file, keyfile.omk. So all password files for this software, Roof and Deck, it has to be of the extension omk.omk. And if I open this, there'll be two lines. The first line is the password, and the second line is the salt. Since we are going with the GCM mode, GCM uses both password and salt. If you're choosing ECB, you do not have to specify the second line. But when you choose GCM, you have to go with you have to specify a password and you have to specify salt. And the password and the salt can be of any arbitrary length. It doesn't need to be of this many characters. It's not like you have to specify 15 or 16 characters in length. Since we are using a password-based key derivation function, so you don't have to do that. You can have any length you want in your password file, and you provide this file for the encryption. All right. So the way to do that is, imagine I have moved my file into here. So I can just say keyfile.omk, right? So that will provide the password file for the program. And finally, there is this -d parameter that's going to delete your source. So what that does is, if you have once it successfully encrypts the files which are there in the source, if you do not want to maintain this source anymore, it's going to remove all those files from the encrypt this folder, and that's it. So for the moment, I'll just not use this -d, and we'll just run it. All right. So let's take a look at this output. So the first thing is validating if the source directory has any encrypted files. So what this step it's doing is that it's checking if there are any encrypted files which are already placed in this encrypt this folder. Uh, the reason to do this is you should not be encrypting files which are already encrypted. So if there are any encrypted files, there's no need to do double encryption, and it's a bad practice. And for that reason, this program refuses to encrypt any files which are already encrypted. So the first step verifies if there are any files like that. If you have any files of such sort in your input folder, then it's going to stop right here at this line. So this project is issued under these two licenses. It is open source, so you know what it means. Next comes to the execution. So the we have printed some operational info. So the source directory you have provided is this, and the target directory is this. Are you going to delete any source files? That's false. And this number of directories will be created in the target directory. So this program has gone into this encrypt this folder, and it has counted how many directories it has under this folder. It has identified 96 folders under this single folder, and there are 390 files which belongs in this in the source directory. So the number of threads which we are going to use is 8. All right. And then we are going to do an encryption. The operation which will be the mode will be AES-256 GCM. So the encrypted files, once it does the encryption, those files will be placed in this folder, and they will be denoted with the extension .enum. All right. Um, I have just randomly chosen that name, enum. Next is there is this key which gets generated for the password. So if your password is weak, it's going to generate a strong key. And finally, there is some warning message. You have to follow some rules while you use this program, and you have to use it at your own risk. You cannot blame me for wrecking your machine. You just need to fully understand what this tool does and then how to work with it. Otherwise, you should just avoid from this altogether and go with the paid versions. So, what are the rules? So, the first rule is make sure that you are trying to not decrypt unencrypted files or encrypted already encrypted files. So basically what it means is if you have any unencrypted files, you should not try to decrypt them because they are not encrypted in the first place, right? So at this moment, these files are not encrypted. So you should not be trying to decrypt the files. And then the other one is encrypt already encrypted files. So if there are any encrypted files, you should not be trying to do that. Even though the program refuses to do that in the very first step, it's not a good thing to do. So you should avoid doing that. So that's the first unbreakable rule. The second rule is to it's just with the kind of nature of the files which you're providing to this program. So if there are any files which has UTF uncompatible data, so basically any binary file or an executable file, those will not have UTF-8 compatibility. There will be some random strings, and so those are not valid UTF-8. If you have any files like that, then this program will either skip such files or will try to encrypt those files, but ultimately those files will be unusable, right? When you try to decrypt them, you can decrypt them, but if it is a binary file which you're trying to encrypt, say you have an executable and you are trying to encrypt the executable with this program, uh, after you decrypt it, it will not be usable, right? So that's the second rule. Now the third rule is if you are using GCM mode for encryption, then you should not try to decrypt it with ECB and vice versa. All right. So when you do that, when you encrypted the files with GCM, but you are trying to decrypt with ECB, that's going to totally fill your target files with garbage. Your source, as long as you are not deleting your source files, your source directory is fine. But your target, your target files will be totally filled with gibberish. All right. So that's the third rule, and the last and final rule is when you the file names which you pass to this program. So all the files which are there in this in these folders, you should ensure that you do not have any strange characters here. All right. So strange characters, I mean like ampersand. You should not have such kind of characters. If it is alphanumeric and if there are spaces, as long as it's alphanumeric, it is fine. And you just need to test this out. I haven't fully tested it yet. What are the different file names which I can use? I'll try to do that, rectify that in a later version. But for now, you just understand that whatever files you pass to this program, those files needs to be alphanumeric, and they can be spaces. As long as you stick to these, uh, your files will not be misplaced in weird locations in your drive. So if you have a file with a unique weird character in between, it will just go place in some other location where you will not be able to. So you thought that okay, the encryption happened, but you don't find the file in your output directory, but the file is present in some other location. Okay, so that's the result of it. All right then. So we have gone through a lot. Now I'll just type in yes. So it just has encrypted the files. Since there are only very little number of files, 390 files, it just happened uh, like in a fraction of a second. So it just took 1.8 1 second seconds to complete. All right, so it has successfully finished all the 390 files under that encrypt this folder, and then it has provided us with an output. So as you can see, there is this output, decrypt this folder, and then so it has encrypted all my files with a .enum extension, so I can just go to any level. This way, what I'm trying to solve with this tool is to not go ahead to not individually encrypt files. That will be a tedious task, right? So that's the actual main agenda of this program. Because I just want these files to be immediately accessible, meaning if I want to just decrypt this file, I can just pull it out to some other location and then decrypt it. I do not have to encrypt my whole disk to keep these files safe. And at the same time, I do not want to zip them together so that I just extract a bunch of files to just get to one single file. All right. So everything is encrypted. So you can see this video file is of 69 MB, and it has just done it in a matter of 1 second. I can just open any of this file and show you how the content inside looks. So it has fully encrypted it. Okay, nothing is visible. You may have some questions like, are you using the same key for all these files? No, I'm not. There is a nonce. In cryptography, there is a concept of nonce, and then I'm generating a unique nonce every time to encrypt a new file. So a unique nonce is generated, which means that there is no scope of trying to crack the key based on some loopholes between two different files. All right. So um, so that's the high level of it. So I have encrypted this. Now I can safely delete this whole drive. All right. So I can just delete it, and then let's try to decrypt the files. So two things. We don't need to provide this password. Okay, let's provide the password file for now. Mm, So decrypt this folder is the source, and then this time I'll just say encrypt this folder as the target, and I'll just say I'll have to be careful here. I just said decrypt, and I'll try enter. Every time you run this program, it's going to give this warning message, so that you'll be careful. So there are again 96 folders, 390 files, and then 8 threads. We are trying to decrypt. It's a GCM. So the source folder, target folder, and then the enum extension, it has generated a key for us. Uh, and then let's try to decrypt. So it has finished in just 1.49 seconds. I can go here and I can just take a look at my files. Yep, my data is there. It's all, it's looking good. So my data is there. Everything's back to normal. All right. So uh, that's just a high level overview of encryption and decryption. Now you can go ahead and delete any of this. I mean, as I've shown you, you can try to output the encrypted files under a target directory. But what if you do not want to do that? All right. So imagine a scenario where you have your files in you have your encrypted files in your decrypt this folder. So we still have it. Let me just delete this. So you have the files here, and I do not want to generate a separate folder or a directory for my original files. All right. So to do that, all I just need to do is I do not specify the target directory, and I'll also mention -d option so that it will delete. So what this basically does is if I do not specify this target directory, those original files will be back in the same folder. All right, so it will be placed in the same folder, but your encrypted files and your normal files will get mixed up. So just to be safe, I'm deleting the source files. So I'll just try to do this, run. Now let's take a look at the output. So we can see that delete from source is true, target is not specified, and I'm trying to do a decrypt. .enum extension, same error message, and then I'll just say yes, and it has finished in 1.8983 seconds. So I am just back to my decrypt this folder. Just a second ago, you have seen the files in this folder are encrypted, but now it has fully decrypted them. All right. So we have decrypted it. Um, and then what else is there? Okay, so now if I want to encrypt this once again, I'll just say encrypt. All right. And one more, I don't have to provide this password file here all the time. Now, right. So here's the thing. When I didn't provide the password file, I'm trying to encrypt the same thing again back because I have the original files here, and then I'm going to encrypt now. But this time I haven't provided a password file. So what does this program do? So this Okay, so this is this is the way it works. If you just take a look at the actual help section, then it will be a bit clear, but I'll just explain it. So first it will try to check if you have provided any password file. If you didn't, then it's going to say that you didn't provide it, and maybe you are missing the file with an extension .omk. So if you do not provide your password file with .omk extension, if you have something else, it's not going to accept it. All right. um, Searching for a password file on your machine, and it ends with an OMK, and it just searches for the file, and it starts searching based on an order, and then that order is also specified here. I have mentioned it here. So first it will look at the current directory, which is your dot, and then it will go two levels back. So wherever you're running the program, so I'm running this program in this test folder, right? So it first looks for the file inside for the key file outside this test folder, and then in two levels behind it, so it'll also look into the pictures folder. If it doesn't find it in those two places, then it is simply going to go and check the /etc folder. So /etc in your Linux machine will be this, so /etc/config. Okay, so that if you put your omk file somewhere here, then it's going to look for that, or else the next place it's going to look as /home, and finally it will go to /root. If it has covered all these places, and if it still doesn't see a .omk file, then it's going to ask you to manually enter the password and password and salt. Okay, so as you can see here, it has just found the key file dot omk somewhere in the uh, where is it? It has found it here. All right. So it has found the key file, and so it's saying whether you want to proceed with it. I'll just say yes. All right. So if I just say yes, what happened? So I didn't provide the yes correctly, so it has to be capital Y. So since I gave it as small y, uh, it identified it as no. So it says, okay, you need to enter the password manually, which I don't have. If I try to provide some passwords which is not the correct ones, it's going to start, but there is a you would soon find out that wait, okay, it's not going to decrypt it. Okay, okay, it's just going to fail in between. All right, that's what's going to happen. You can experiment with it. All right. Um, Now I'll just go through this once again. So let's try capital Y. Yes, I want to do this, and then again capital Y. Yes, it has done it. So I'll just go into this. Yeah, I see the files are back to the encrypted state. Okay. Um, so what if, uh, like I said, if you do not provide the password file, and if you do not maintain it at any places, if you do not have it, if you just remove it altogether, then it's going to ask for you to provide the password and username, password and the salt manually. And you don't have to, while you type your password, it is not going to print it. It's going to be invisible, so that if your system is compromised, no one can see it. If you have a keylogger on your machine, then only on, you cannot. I don't know what to do in that case. You just need to get rid of your system, throw it in a garbage. I'm just kidding. So if you have a keylogger, you just completely um, redo the whole thing, reinstall the OS, get rid of it, and then do things from scratch. Okay, so that's the mm, complete total demonstration of Roof and Deck. All right, you can explore with it. If you wish to contribute to this project, feel free to. So it is open sourced, as I said, and then these are licensed under Apache and MIT. So any source code which you contribute, if you understand Rust and if you're able to make any changes, submit a pull request. I'll set some rules how to do it. So basically, there will be some rules to raise a pull request, and then if I like a feature, I'll accept it, and that's it. All right. Thanks a lot. See you again.